Good morning. Other object in the solar system. Introduction. As you know, there are 8 main planets in the solar system. We also know other objects in solar system besides the sun, the planets and their moon, such as asteroid, meteoroids, craters and comet. This is the image of solar system. Asteroids. Asteroids are rocky objects that move around the sun between the orbit Mars and Jupiter. This path is also called asteroid belt. Scientists believe that they are materials left over from the time the planets were found. This is the image of asteroids.
Good morning. Comets. Comets are balls of ice, dust and gas that travel at great speed around the sun. As a comet comes close to the sun, it heats up and the dust and gases from a long glowing tail. One of the famous comets is the Halley's Comet. It's visible only from the Earth every 75 to 76 years and it's visible without a telescope. This is an image of Halley's Comet. Thank you.
Parts of comets. The main part of comet is called the nucleus. It is made of frozen water and gas plus dust and rock. The nucleus usually measured a few miles across. When the comets get close to the sun is the comma is larger than the Earth. It makes the head of the comets is look blurry. When comets moves even closer and to the sun grows stale. This happened because the sun moves of energy and streams of particles. The comma style lasts only while the comet is fairly close to the sun. Here is image of Halley's Comet. Thank you.
Good morning everybody. Meteorites and meteor. Meteorites are small pieces of rock that travels around the sun. Some of them are pulled toward the earth. As they come closer to the earth, they start burning. The streak of light produced by the burning meteorites are called meteor. Here is the image of meteorites and meteor. Thank you.
Greeting. The project is done with Scratch Junior. Kicking the planet, it says, I am a Saturn. I am a Earth. I am a meteoroids and I am a asteroids. Thank you.
I am Pratik Naveen of class 4B from BVM Global Trichy School. This year, for Project D 2021 in our school, the topic is galaxies, universe, solar system, moon, etc. So let's start about the galaxy. A galaxy is a gravitationally bound system of stars, stellar remnants, interstellar gas, dust, and dark matter. The word galaxy is derived from the Greek galaxias, which means Milky Way. a reference to the Milky Way galaxy. Galaxies range in size from dwarfs with just a few hundred million stars to giants with 100 trillion stars, each orbiting its galaxy's center of mass. Galaxies are categorized according to their visual morphology, such as elliptical, spiral, or irregular. Many galaxies are thought to have supermassive black holes at their centers. The Milky Way's central black hole, known as Sagittarius A, has a mass 4 million times greater than the Sun. As of March 2016, GN-Z11 is the oldest and most distant galaxy observed. It is a car-moving distance of 32 billion light years from Earth and is seen as it existed just 400 million years after the Big Bang. Next, also the solar system. A solar system is a gravitationally bound system of a star and the objects which orbit it, either directly or indirectly. Of the objects that orbit the Sun directly, the largest are the 8 planets, the dwarf planet and the small solar system bodies. Of the planets that orbit the Sun indirectly, they are Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus and Neptune. And there are some objects which orbit the Sun indirectly. The natural satellites such as the Moon, Phobos and Deimos, the natural satellites of the Moon, the planet Mars, Ganymede, Callisto, Io, Titan and other moons which orbit the planets Jupiter, Saturn, Uranus and Neptune respectively. The solar system formed 4.6 billion years ago from the gravitational collapse of a giant interstellar molecular cloud. The vast majority of the system's mass is the Sun. The majority of the remaining mass contained in Jupiter. 4 smaller inner system planets, which are Mercury, Venus, Earth and Mars, are primarily composed of rock and metal. The 4 outer system planets are giant planets, being substantially more massive than the terrestrial. The 2 largest planets, Jupiter and Saturn, are gas giants, being mostly composed of hydrogen and helium. The 2 outermost planets, Uranus and Neptune, are ice giants, being composed of mostly substances with relatively high melting points compared with hydrogen and helium, called volatiles such as water, ammonia and methane. All 8 planets have almost circular orbits that lie within a nearly flat disk called the eclipse. Next is the galactic clusters. A galaxy cluster or cluster of galaxies is a structure that consists of anywhere from hundreds to thousands of galaxies that are bound together by gravity, with typical masses ranging from 1014 to 1015 solar masses. They are the largest known gravitationally bound structures in the universe and were believed to be the largest known structures in the universe until the 1980s, when superclusters were discovered. One of the key features of clusters is the intracluster medium. The intracluster medium consists of heated gas between the galaxy and has a peak temperature between 2 to 5 keV that is dependent on the total mass of the cluster. Galaxy clusters should not be confused with star clusters such as galactic clusters, also known as open clusters, which are structures of stars within galaxies, or with globular clusters, which typically orbit galaxies. Small aggregates of galaxies are referred to galaxy groups rather than clusters of galaxies. The galaxy groups and clusters can be are referred to as galaxy groups rather than clusters of galaxies. The galaxy groups and clusters themselves cluster together to form superclusters. Supercluster. A supercluster is a large group of smaller galaxy clusters or galaxy groups. It is among the largest known structures of the universe. The Milky Way is part of the local group, galaxy group, which contains more than 54 galaxies, which in turn is part of the Virgo supercluster, which is part of the Lagrange supercluster. The large size and low density of the superclusters mean that they, unlike clusters, expand with the Hubble expansion. The number of superclusters in the observable universe is estimated to be 10 million. The universe or the observable universe. The universe, or in Latin, universes, is all of space and time and their contents, including planets, stars, galaxies, and all other forms of matter or energy. The Big Bang theory is the prevailing cosmological description of the development of the universe. According to estimation of theory, space and time emerged together 13 billion years ago, and the universe has been expanding ever since. While the spatial size of the entire universe is unknown, the cosmic inflation equation indicates that it must have a minimum diameter of 23 trillion light years, and it is impossible to measure the size of the observable universe, which is approximately 93 billion light years in diameter at the present day. My presentation. Thank you.
The Sun and the Solar System. The planets are rotating to the planets are rotating in the line. It cannot cross the line. The line name is orbit. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. These are the planets. How do we edit means? The color was in yellow. We can choose the color here. It is rotating. We can choose whatever color we want. There is the color option. We put the circle in a line. You can make it. Thank you.
Good morning. My name is Mahita. I'm studying in class 5B. I'm from VVM Global Trichy. Today I'm going to take the topic dark planets. So I'm going to explain it. So dark planets are planets which appears to be the darkest before it's seen. So next is, what is the most darkest planet ever discovered is TRES 2b. So it is an extrasolar planet orbiting the star called GSC. So it is located 750 light years away from the solar system. So this planet is identified that there is a planet like this in 2011, and this is the darkest ever planet known, exoplanet known. So it will reflect less than 1% of any light that hits it. This is the picture of TRES 2b. Next, darkest world enlightens astronomers about mysterious light gobbling planet. This fun fact is said by Morgan Kelly. So, Milky Way galaxy is surrounded by the dark planets like Tress-2b. This is the Milky Way galaxy which is surrounded. Thank you.
Hello everyone, I'm PM Mitra Shivani of Class 5A studying in BVM Global at Trichy. Now we are going to see a PPT of International Space Station and satellites. Information about the satellites. It flies around the world every 90 minutes, traveling at 5 miles per second. In the space for just 24 hours, the space station makes 16 orbits of the Earth, traveling through 16 sunrises and 16 sunsets. It's 357 feet long from end to end. That's about the same as a football pitch. 6 spaceships can dock to the station at any one time. The electrics on the ISS are connected with 8 miles of cabling. The ISS weighs about 420 kgs. That's about the same of 320 cars. Peggy Wilson set the US record for spending the most total time living and working in space at 665 days on September 18. 8 spaceships can be connected to the space station at once. More than 50 computers control all the systems on the station. It was launched in 8 astronauts have been living on board ever since. Two things are infinite, as far as we know, the universe and the human stupidity. Albert Einstein. Information about the satellites. Satellites travel at 18 per hour. All planets in the solar system except Mercury and Venus have natural satellites. Sputnik 1 was about of a beach ball that took about 98 minutes to orbit the Earth. Skynet 5B has satellite wing the size of very large corridor. 1/4 of the world's telecommunication satellites are made at Airbus in Stevenage. 40% of the world's smallest satellites are made in the UK. There are over 2,500 satellites in orbit around the Earth. A satellite gets better fuel economy than Paris. The bird's eye view that satellites allows them to see large areas of Earth at one time. I had always seen myself as a star. I wanted to be a galaxy. Vailata. Types of satellites. Communication satellite, remote sensing satellite, navigation satellite, geocentric orbit type satellites, LEO, MEO, HEO, global positioning satellite, GPS, drone satellites, ground satellite. Sputnik 1 was the first artificial Earth satellite. It was launched into an elliptical low Earth orbit by the USSR on October 4, 1957 as part of the Soviet space program. Its weight was 184 grams, 83 kgs and was 23 inches, 58 centimeters wide. This is the picture of Sputnik 1. First astronaut in space. Yuri Gagarin was the Soviet pilot and cosmonaut who became the first human to journey in outer space, achieving a major milestone in the space race. His capsule Vostok 1 completed one orbit of Earth on 12 April 1961. He is Yuri Gagarin. Thank you.
Good morning everyone.
This is Dia from B1 Global Activity. Now we'll be showing about satellites and space stations of basics of coding. How to create a game. This is Caroline, and this is Millie. You can see these hunger thirst of Willie and Caroline. If I press Caroline's her water, it will decrease. And when I press this, she eats it. And it also decreases. And her thirst also. Even Millie's, if he eats, it decreases. This is about Millie's coding. This is Caroline's coding. The spaceship's coding. The back and front coding, which is like this. The press front coding. The bed coding. The fruit salad coding. Water.
Good morning, everyone. I'm Travis of 6B. Mercury. There are no seasons on Mercury. Seasons are caused by a tilt of axis relation to the planet's orbit. Since Mercury's axis is directly perpendicular to its motion, it has no seasons. If you were on the surface of the Mercury, the sun would look almost 3 times as big as it does from Earth. Venus. Venus also has a smaller orbit than Earth, which makes its season shorter and particular in temperature and conditions. Extremely slight. Its season lasts near 55 to 58 days, opposed to 90 to 93 days on Earth. Mars. Similar to Earth, Mars has 4 distinct seasons. However, each season lasts about twice as long because the Martian year is almost twice than that of Earth. Mars orbit closest to the Sun when its southern hemisphere it is tilted towards it, while the north hemisphere is tilted towards the Sun when it will faster away. Jupiter does not have changing seasons like the Earth, but instead is believed to have a constantly stormy atmosphere. This is partly due to its tilt, which is only 3 degrees. The planet has a very troubled atmosphere and it is believed to have a lot of long-term storms. Saturn. It is around 28 Earth, 28, 29 Earths year to orbit the Sun, making each season of Saturn more than the 7 Earths year long. Earth is tilted with respect on the Sun, which allots the amount of sunlight each hemisphere receives as our planet moves it in its orbit. This rotation in solar energy is what drives our seasonal changes. Uranus. For Uranus, for two 221 years, seasons on Uranus. The winter-summer season, the poles of Uranus are pointed more or less there towards the sun or away from it during Uranus winter-summer season. The winter side of the planet never sees the sun. It doesn't see the sun for 21 longer years.
Good morning. I'm Deepesh from class 6B from Being Global at Neptune axis of rotation is tilted 28 degrees with respect to the plane of its orbit around the Sun, which is similar to the axial tilts of Mars and Earth. This means that Neptune experiences seasons just like we do on Earth. However, since its year is so long, each of the 4 seasons lasts for over 40 years. Climate change is a long-term shift in global or regional climate patterns. Often, climate change refers specifically to rise in global temperatures from the mid-20th century to present. Climate changes includes both global warming driven by human-induced emissions of greenhouse gases and the resulting large-scale shifts in the weather patterns. Though there have been previous periods of climatic change since the mid-20th century, humans have had an unprecedented impact on Earth's climate system and caused change on a global scale. What are the causes of climatic changes? Humans' increased use of fossil fuels such as coal, oil, and gas to generate electricity, power, and other forms of pollution. Power manufacturing and industry, deforestation, because living trees absorb and store carbon dioxide. Good morning. Today we made a solar system. This is background. This is music. Sun. This is how it works. When click, we have to first position the sun. And when the actor click, they say sun, and we use dialogue and pen. We all have same codes as sun. I will run the project.
Good morning to all. I am K.S. Sarvesh from Class 6B from BVM Global at Trichy. Season and weather changes. Season. Weather usually changes in a cycle, that is, in a fixed pattern that repeats itself every year. Such cycles of weather change are called season. Causes of season. Earth's tilted axis causes the season. Throughout the year, different parts of Earth receive the sun's most direct rays. So, when the North Pole tilts towards the sun, it's summer in the northern hemisphere, and when the South Pole is towards the sun, it's winter in the northern hemisphere. Seasons on the Earth. Earth has season because its axis is tilted. Earth rotates on its axis as it orbits the sun, but the axis always points in the same direction. December. Summer south of the equator, winter north of the equator. The sun shines directly on the southern hemisphere. March. Falls south of the equator, spring north of the equator. The sun shines equally on the southern and northern hemisphere. June. Winter south of the equator, summer north of the equator. The sun shines directly on the northern hemisphere and indirectly on southern hemisphere. September. Spring south of the equator, fall north of the equator. The sun shines equally on the southern hemisphere and northern hemisphere. Why is it hot in summer and cold in winter? It is all about the tilt of the earth axis. Many people believe that the temperature changes because the earth is closer to the sun in summer and farther from the sun in winter. In fact, the earth is farthest from the sun in July and is closest to the sun in January. During the summer, the sun's rays hit the earth at a steep angle. The light does not spread out much, thus increasing the amount of energy hitting any given spot. Also, the long daylight has allowed the earth plenty of time to reach warm temperatures. During the winter, the sun rays hit the earth at a shallow angle. These rays are more spread out, which minimizes the amount of energy that hits any given spot. Also, the long nights and short days prevent the earth from warming up. Thus, we have winter. Thank you.
Hello all, I am Vimal R of Class 6B from BVM Global at Trichy. This coding that we have made is to raise awareness about cutting trees. This is the coding for the stage. We have a stage, tree, a shovel and a title. For the stage, the coding is that on the start it should clear the whole stage. And the coding for the tree is that on the start it should always go to the mouse pointer. And when we have clicked the mouse, it should start growing, and then it should delete clone that it has made as soon as it's finished after stamping it. Now we will see the shovel sprite. On the start, it should always go to the mouse pointer like the tree. When the mouse is clicked, it should create the clone of the tree and play this sound, crunchy bite. And then this is the title, there is no code here. Now I will run the program. As you can see, the shovel is following the mouse pointer. When I click it, the tree will grow. Thank you.
Hello everyone, I am Harni with my friend Deepta, here to present you a PPT on the topic light pollution. So let's start. First, what is a light pollution? Light pollution is blamed for compromising health, disrupting ecosystems, and spoiling aesthetic environments. It is defined as any adverse or bad effect as a result of a man-made light, which is unnecessary light around the world. So, what causes it? Light pollution or excessive inappropriate use of outdoor artificial light, that earthly sky glow. Light pollution is a global issue. It is mainly caused by misdirective, excessive, inefficient and unnecessary lighting systems. The main culprit is the street and vehicle light, advertising light and industrial lights. So, light pollution on Earth in the past. Light pollution started to become a problem in the early 20th century around the time city began adopting electric light. Awareness of deleterious effects of light pollution began in the second half of the 19th century, but efforts to address effects did not begin until 1950s.
Effects of light pollution. Light pollution has a wide range of negative effects on human health, such as disrupting our circadian rhythms, messing with our melatonin levels, and generally contributing to sleeping disorders. It is affecting human health, wildlife behavior, and our ability to observe stars and other celestial objects. Light pollution on Earth in present. Singapore was found to be the most light polluted country in the world. Another study from 2017 suggested that worldwide light pollution increased by roughly 2% a year between 2012 and 2016. It has been estimated that 83% of the world's people live under light polluted skies and that 23% of the world's land area is affected by sky glow. The area affected by artificial illumination continues to increase. Did you know that there is a dark place which is known as the Natural Bridges National Monument? It has zero light pollution, and the sky at the Cherry Springs State Park. With the sky, we can see the Milky Way as it is so dark. It became the second darkest place. The light pollution would disappear when we decrease the use of electricity and lights. Dimmers, motion sensors, and timers, they can help us to reduce the light pollution. How can we reduce light pollution? We can use the way of timers, motion sensors, and lightning zones. We can decrease the use of decorative lights. We can use covered bulbs. We can use LED lights. Thank you all. Hope you understood what is light pollution, how it is caused, light pollution in the present and the past. Thank you. Let us all save our earth from light pollution by reducing the use of electricity.
Hello everyone. So this is the project we made related to light pollution. So escape from the light pollution is a chasing game. The software we use for this is Scratch Desktop. There are 4 sprites: Earth, Star, Torch and Game Over. So whenever Earth touches Torch, the life increases by 1. and when Earth touches star, the score increases by 1. If there are 5 lives, there are 5 lives in total. If all the 5 lives are completed, the game automatically gets over and the game over appears on the screen. So, now let's see the coding of this. So this is the coding of Earth. And this is the coding of torch, which is light pollution. This is star and this is game over.
Hi, I'm Deepta here to explain the output of the game Escape from Light Pollution. So see here the earth. So the torch is affecting the earth. So to get rid of the light pollution, the earth should touch the star. So they have 5 lives. We have 5 lives.
Space debris. Me and my friend is going to do a project on space debris. Debris in space. Now I welcome my friend Nagul to read this.
Debris in space. Space debris are defunct artificial objects in space, principally in Earth orbit, which no longer serve a useful function. Space debris, also called space junk, artificial material that is orbiting Earth but is no longer functional. This material can be as large as discarded rocket stages or small as microscopic chip of paint. What is largest piece of space junk? Australia already holds the record in category of who can be hit by biggest piece of space junk. In 1979, the 77-ton US space station Skylab, this integrated over Western Australia, preparing the area around the southern coastal town of Esperance with fragments.
The first successful demonstration of types of space debris. Space debris comes into 2 types, natural and artificial. Natural space debris consists of small pieces of cometary and asteroidal material called meteoroids. Artificial space debris is any non-functional man-made object in space, usually orbiting the Earth. Can space junk be cleaned up? Clear Space 1, the European Space Agency's mission to remove space junk from orbit, is expected to be launched in 2025. This mission will use 4 robotic arms to capture the debris. A 2018 demonstration mission successfully deployed a net ensnare space junk.
What is the most famous piece of the space junk that has fallen onto Earth? Weighing in at nearly 18 tons, the empty core stage from the rocket is the largest piece of space debris to fall uncontrolled back to Earth since 1991 and the 4th biggest ever. The only larger pieces were Skylab in 1979, Skylab's rocket stage in 1975, and Salyut 7 in 1991. 11 May 2020. Removing debris. There are 4 techniques that can move debris from heavily trafficked orbits. First, deorbiting, the deliberate forced re-entry of the space object into the Earth's atmosphere by application of a retarding force, usually via propulsion system at EOL. The second, orbital lifetime re-eruption, accelerating the natural decay of spacecraft and other objects to reduce the time that they remain in orbit at EOL.
Three moving objects into less populated disposal orbits at the end of their functional lifetime and active removal of debris. Astronauts and spacecraft engineers must be careful because even the smallest loose nut or bolt lost on spacewalking repair mission could cause the cascade of debris. Thank you. This PowerPoint is by Brahadish Dharanjan and Nagul.
Today, now we are going to show the coding we did for scratch. When flag click set score to 0, hide, repeat 20 times. In that repeat 20 times, create clone of myself.
When sprite click, switch costume to burst. Wait 0.3 seconds. Change the score by 1. Delete this sprite. Delete this clone.
When I start as a clone, show switch costume to rocks. Point in direction, pick random -90 to 180. Go to X, pick random -50 to 150. Y, pick random -150 to 150. Change color effect by pick random 1 to 200. Forever, in forever, move 1 step. If on edge, bound. This is the coding for rocks. Now we can go to the coding of the background. When flag clicked, switch backdrop to wall 1, set time to 10, repeat until time is equal to 0. In repeat until time is equal to 0, wait 1 second, change time by -1, broadcast game over, stop all.
When I receive game over, switch backdrop to game over.
Now, we are going to show the output. Thank you.
Warm greetings for our project team. This is Ragothaman and Suhail. We explain about features of space vehicle and exponent usage in space astronomy. After this PPT, you have some codings done by Suhail. And let's go with the presentation.
Astronomy in space. Astronomy is the study of everything in the universe beyond Earth's atmosphere. That includes objects we can see with our naked eyes, like the sun, the moon, the planets, and the stars. It also includes objects we can only see with telescopes or other instruments, like faraway galaxies and tiny particles.
Characteristics of space astronomy. Astronomy is often, but not always, about very concrete, but it's observable things. Whereas cosmology typically involves large-scale properties of the universe and esoteric. It is invisible and sometimes purely theoretical. Things like string theory, dark matter and dark energy, and the notion of multiple universes.
Importance of astronomy. On a more pressing level, astronomy helps us study how to prolong the survival of our species. For example, it is critical to study the sun's influence on Earth's climate and how it will affect weather, water levels, etc.
Exponents uses in space astronomy. How are the exponents used in space astronomy? Astronomers work with very large and very small numbers. Any number can be expressed as the product of two other numbers. Here, the 10 is called the exponent. The exponent is the number of zeros which follow the initial number called the mantissa.
Features of space vehicles. The US Space Shuttle consisted of three major components: a winged orbiter that carried both crew and cargo, an external tank containing liquid hydrogen or fuel, and liquid oxygen or oxidizer for the orbiter's three main rocket engines, a pair of large solid propellant strap-on booster rockets.
Astronomers using exponent. Using an exponent to represent a number allows that number to grow very big or very fast. This makes it convenient to represent very large or very small numbers using exponential notation. A number written correctly in scientific notation has two parts. Thank you for your patient listening. Thank you so much.
Thank you.
Everyone, my name is Suhail and this is my Robotics Project Day project. So, for backgrounds, I just kept a normal background, a black background. For stars number 1, when scene starts, place at x0, y0, glide 5 seconds to x negative 720 and y0, place at x 720 and y0 forever. Glide 10 seconds to x negative 720 y0, place at x 720 y0, end of loop. And stars 1 looks like this. Stars number 2. When scene starts, place at x 720 y0 forever. Glide 10 seconds to x negative 720 and y0, place at x 720 y0, end of loop. And it looks like this. And then UFO. So the coding for it is when scene starts forever, glide 1 second to x random value, y random value, set size to 50%, end of loop. Then when scene starts forever, set size to 50%, wait 0.2 seconds, end of loop. When tapped, start sound UFO. This is the UFO looks like, and this is the sounds, which I will show you later. So when I click to play the output, this is how it is. It glides around, and if we touch the UFO, it makes that sound. And this coding goes on forever, and whenever we press UFO, it makes that sound.
I wish a very good morning to one and all gathered here. Me, Hari and Jasim present here with our coding presentation. Our topic is astronomical units, numbers in astronomy and geometry and space astronomy. Astronomical unit. The astronomical unit is a unit of length, roughly the distance from Earth to the Sun, and equal to about 150 million kilometers or 8 light minutes. The actual distance varies by about 3% as Earth orbits the Sun from a maximum to a minimum and back again once each year. Let us take a look about our astronomical unit. Characteristics of astronomy. Astronomical units AU or AU, a unit of a length effectively equality to the average of mean. Distance to the between the Earth and the Sun defined as a 149, 597, 870.7 kilometers and 92, 955, 807.3 millis. What are astronomical numbers? The astronomical unit AU, 1 AU is the mean distance from the Earth to the Sun. 1 AU is equal to 1.4596 into 108 kilometers. The AU is used for expressing the distances between planets. In round numbers, you can use 1 AU is equal to 150 million kilometers for the purpose of this class.
What does 7 mean in astronomy? It means that the tiny object is spinning and that our hot spot on the surface is rotating into our line of vision every 7 seconds. In the same way, that lighthouse spins in a deep of a light around in a circle.
Number in astronomy. Thus, light covers 3 into 105 km per second into 3.6 into 103 SH is equal to 1.8 into 109 km per hour. There are 24 or 2.4 into 101 hours in a day and 365.24 3.65 into 102 days in 1 year. The product of these two numbers is 8.77 into 103 HY. Multiplying this by 1.8 into 109 km gives 9.46 and 1012 km per light minus year.
How is geometry used in space? Geometry is very important to NASA scientists and engineers that are plan missions to Mars and other bodies in the solar system. The knowledge of geometrical shapes and can help them understand how planets move, how to send the spacecraft from Earth to reach those planets.
What is geometry and space? The geometry of space is defined by the three dimensions that all objects have in the real world. The geometry of space is used in architecture and engineering to make sure all parts of a bigger object fit together as needed.
How is math used in astronomy? Astronomical, you use math all the time. One way to use in when we look at the object in the sky with a telescope. The camera that is attached to the telescope basically records of a series of numbers. Those numbers may correspond to the how much light different between in the sky or emitting the type of a light, etc.
What are the three types of geometry? There are three types of geometry that are Euclidean, spherical, hyperbolic. And
A very good morning to one and all gathered here. Me and Harry present here with our coding. Our topic is astronomical units, numbers in astronomy, and geometry and space astronomy. So we can start our game.
This is the game that we have coded it. The concept of this game is to avoid the asteroids that are coming from here. Yes, see, I have avoided one asteroid. If we hit that asteroid, our spaces will be blasted. If we hit it for continuously in 3 times, it will blast and the game will restart. Thank you. That's all for today. We will meet you in another video. It's me, Jasim, and Harry present here.
thank you. See you next time. This is me, Jasim, and Harry signing off.
Hello everyone, we the students of class 9 are here to do a presentation on space.
Table of the Big Bang theory. Robotics in space, gravity and vacuum in space, space-time and space force.
The Big Bang Theory. The Big Bang Theory is how astronomers explain the way the universe began. In 1927, an astronomer named George Lemaître had a big idea. He said that the universe started at a single point and is now stretched this big and it be stretching. 2 years later, an astronomer named Edwin Hubble noticed and said that other galaxies are away from us. The farthest galaxies were moving faster than ones close to us. This meant that universe was still expanding just like Lemaitre thought. When the universe began, it was just hot, tiny particles mixed with light and energy. The tiny particles together formed the atom. They again formed stars and galaxies. Stars and galaxies started dying. These things formed asteroids, planets, comets, etc. The universe is 13.8 billion years old. That's very long and it's still stretching. Hence, we call it as the Big Bang Theory.
Robotics in space. The Space Robotics Technical Committee has two main areas of interest, microgravity and planetary robotics. Microgravity robotics includes manipulation of mobility for scenarios such as International Space Station (ISS) operation and satellite servicing. Some scenarios such as asteroid and comet exploration have environment with low gravity which may blur the distances between these categories. Remotely operated vehicles (ROV) and remote manipulator system (RMS) are two major types of space robots.
Space, time and distance. The space-time and distance is a contextual model combining the 3-dimension of space with the 4-dimension of time. The space-time explains the unusual relativistic effects which arise from traveling near speed of light and motion of massive objects. The physicist Albert Einstein helped develop the idea of space-time as a part of his theory of relativity. Space-time starts to depend on each other so that the speed of light keeps constant.
Gravity in space. Gravity causes every object to pull every other object toward it. Some people think that there is no gravity in space. In fact, a small amount of gravity can be found everywhere in space. Gravity is what holds the moon in orbit around the Earth. Gravity causes Earth to orbit the sun. It keeps the sun in place in the Milky Way galaxy.
Space Station. 20 years since the International Space Station, the ISS, first started orbiting the Earth. Astronauts living in the board ever since from 1998. The International Space Station, ISS, is a modular space station in low Earth orbit. It is a multinational collaborative project involving 5 participating space agencies. The ownership and use of space station is established by intergovernmental and agreements.
Vacuum in space. A vacuum is an empty place which space nearly achieves. Space is an almost perfect vacuum, full of cosmic voids. Space is almost an absolute vacuum, not because of suction but because it's nearly empty. The emptiness results in extremely low pressure. When our body comes to contact with vacuum of space, will pull the air from your body.
The image of space station.
Thank you.
Let's explore black hole in space. A black hole is a region of space-time where gravity is so strong that no particles or even electromagnetic radiation such as light can escape from it. Let's start.
Hello everyone, greetings. I'm Anuja of class 9. So I'm gonna explain the Big Bang theory using an animation which I made using Snap software. The Big Bang theory is the most commonly accepted theory among the scientific community. So according to Big Bang theory, 1 second after the Big Bang, the universe was filled with neutrons, protons, electrons, anti-electrons, photons and neutrinos. Few minutes later, the temperature cooled from 100 nonillion 1032 Kelvin to 1,109 Kelvin. Roughly 38 lakhs years after the Big Bang, matter cooled enough for atoms to form. However, after this point, the universe was plunged into darkness since no stars or any other bright objects had formed yet. About 400 million years after the Big Bang, the universe began to emerge from the cosmic dark ages. A little after 9 billion years after the Big Bang, our solar system was born. Thank you.
Good morning all. My name is Kaushik along with my friend Malolan here to explain about our presentation on the topic India's contribution to space science and India's contribution to robotics. So let's get going. Introduction. Indian space program encompasses research in areas like astronomy, astrophysics, planetary and earth sciences, atmospheric sciences and theoretical physics. AstroSat. AstroSat is the first dedicated Indian astronomy mission aimed at studying celestial sources in X-ray, optical and UV spectral bands simultaneously. Mars Orbiter Mission. Mars Orbiter Mission is ISRO's first interplanetary mission to planet Mars with an orbiter craft designed to orbit Mars in an elliptical orbit of 372 km by 80,000 km. Chandrayaan-1 and Chandrayaan-2. Chandrayaan-1, India's first mission to moon, was launched successfully on October 22, 2008 from SDSC Shah, Sriharikota. The spacecraft was orbiting around the moon at a height of 100 km from the lunar surface for chemical, mineralogical and photogeologic mapping of the moon. Chandrayaan-2. It is an advanced version of the previous Chandrayaan-1 mission to moon. Chandrayaan-2 is configured as a two-module system comprising of an orbiter craft module OC and a lander craft module LC carrying the rover developed by ISRO. So, now let's go to India's contribution to robotics. Introduction. A humanoid robot is a unique robot that has a body shape built to mimic the human figure. The technology can be used for the research of different kinds, including bipedal locomotion or to automate several tasks performed by humans across various sectors. Now, here is my friend Malolan to continue with the presentation.
Good morning everyone. I am Malolan and I am here to continue with our presentation, India's contribution to robotics. Let's go. Sophia is the first robot citizen of the world after Saudi Arabia granted her citizenship in October 2017. It was developed by the Hong Kong-based Hansen Robotics and activated on February 14, 2016. Robotics in India policies. Grey Orange, a company founded by a bunch of Indian techies in 2011, is India's biggest technology company. They have revolutionized supply chain automation. Impediments. Financial incentives. Any company which imports robots into India currently pays about 26.85%. That is 7.5 basic customs duty plus 18% GST plus tax. Important private and public robots in India. Manav, India's first 3D printed humanoid robot, has an inbuilt vision and sound processing capability and is primarily meant for research purposes and is made available to research institutes which offer robotics as a subject to study. These are the types of important private and public India robots. This is Mintra, and this is Kempa, and this is Radha, and this is DRDO Dux. This made in India robot is primarily designed to detect and recover improvised explosive devices. It was inducted by Indian Army around 2011. Using its X-ray vision, Dux can identify a hazardous object and can diffuse it with a jet of water. Thank you for your patient listening. This project was done by Kaushik and me, Malolan. Thank you.
Good morning everybody. My name is Kaushik along with my friend Malolan is here to explain about our program. The name of our program is NASA Perseverance rover. So let's get started. The first stage is ignited at launch and burns through the powered ascent until its propellants are exhausted. The first stage engine is then extinguished. The second stage separates from the first stage and the second stage engine is ignited. Now, here is my friend Maulalan to continue with the explanation.
Good morning everyone. My name is Malolan and I am here to continue with the coding part. The payload is carried atop the second stage into orbit after the successful rocket launch on Mars and start collecting samples of Mars planet. The same program is implemented using STAP Berkeley EDU. Let's see the output. Thanks for watching our program.
Good morning. This is class 11 project, robotics project, and myself and Vishal have done it. And now let us move on into the project. Table of contents. First, Voyager 1 and 2. These are the only two spacecraft which humans have sent beyond Pluto's orbit ever till now, and both have chosen different path in which they are moving. They actually are accelerated and went out of Pluto's orbit with the 4 outer planets' gravitational force. And second topic is calculus in space. Calculus is a very interesting topic which relates both physics and mathematics that can be even used in space. Let us know more in the slide. Life in space. Yeah, life in space is possible. There are some bacteria which was found in IIS, outer sides of IIS, and it lived for 3 years. That's astonishing, right? Psychology in space. Unlike in Earth, psychologically, people will be affected due to many conditions which are totally different. You must be living only in a spacecraft for more than like 3 to 6 months. Like it depends on how much time they do research there. But they must be like, what if we are in a single room for more than 3 to 4 months, and the gravity is not there? Like there are many factors which depends. And chemical reactions in interstellar medium. We'll be seeing more about the reactions and fusion processes which take place inside each star, not each star, commonly in stars. Then aspects of space tourism. Yeah, space tourism is possible. There are people who can travel to space. Even you can travel, but it costs a lot.
The twin Voyager 1 and 2 spacecraft are exploring where nothing from Earth has flown before. Continuing on their more than 40 years of journey since their 1977 launches, they each are more farther away from Earth and the Sun than Pluto. In August 2012, Voyager 1 made the historic entry into interstellar space, the region between stars filled with materials ejected by the depth of nearby stars millions of years ago. Voyager 2 entered interstellar space on November 5, 2018, and scientists hope to learn more about this region through the DSN or Deep Space Network. Adventurous current mission, the Voyager Interstellar Mission (VIM), will explore the outermost edge of the Sun's domain. The 3 unknown species have been discovered growing on the ISS, but don't break out the anti-bac vibes just yet. Don't panic, but 3 strains of bacteria previously unknown to science have been found growing on the International Space Station. In the 1940s and 50s, reports of flying saucers became an American cultural phenomenon. Sightings of strange objects in the sky became the raw materials for Hollywood to present visions of potential threats. connected to ongoing ideas about life on the moon, the canals on Mars, and ideas about Martian civilization, flying saucers have come to represent the hopes and fears of the modern world.
The field is necessary for planning and accomplishing successful human spaceflight missions by ensuring readiness of unique physiological and psychological challenges posed by spending extended time in closed isolated environments like spacecraft. In this slide, actually, we have only mentioned about core, radioactive zone, and conductive zone. Core is the main thing which consists only 20 to 25% of sun's radius, and volume is nearly less than 10%. But it is the most important zone of each star. Let us know why next slide. And in radioactive zone. Radioactive zone is the zone in which the particles are so closely bumped so that even light can't escape there. Like we are getting the light which is nearly 1 million year old due to the scattering effect in the radioactive zone. And in radioactive zone, the convection is not occurring because it is highly dense. Let's see the next. Convective zone. There is 70%, between 70% of the sun's radius, convective zone is visible where the convection of light is seen. Here is where the light is being emitted and it is being released. In radioactive zone, it has been reflected millions of years here and there due to the closely packed molecules. The structure of the Sun contains the following layers. Core, the innermost layer, 20 to 25% of Sun's radius, where the temperature and pressure are sufficient for nuclear fusion to occur. Hydrogen fuses into helium. The fusion process releases energy and the core gradually becomes enriched in helium. Radioactive zone. Convection cannot occur until much nearer the surface of Sun. Therefore, between about 20 to 25% of the radius and 70% of the radius, there is a radioactive zone in which energy transfer occurs means of radiation, photons, rather than by convection. Technoline, the boundary region between the radioactive and convection zones. Convective zone, between about 70% of the Sun's radius and the point close to the visible surface. The Sun is cool and diffuse enough to convection to occur, and this becomes the primary means of outward heat transfer, similar to weather cells which form in the Earth's atmosphere. Because the Sun is gaseous object, it does not have a clear defined surface. Its visible parts are usually divided into photosphere and atmosphere. Photosphere, the deepest part of Sun which can be clearly observed with the visible light. Atmosphere, a gaseous halo surrounded the Sun comprising the chromosphere, solar transition region, corona and heliosphere. These can be seen while the main parts of the Sun is hidden, for example during a solar eclipse. Hope you enjoyed our project. We have made an app in MIT App Inventor and you can still know more about the chemical reactions in interstellar medium topic over there. We have explained about the whole life of a star. Thank you. Good morning, myself Agilesh here, and this is our robotics project which we made it in MIT App Inventor. And this is our screen one. Actually, this is like an introductory screen. I did it, and after clicking the go button, we'll be moving to the next screen. Life of a star. Actually, I made it like a timeline so that it would be interesting to see. First, birth of the star, after that, working of a star, and death of the star has some subdivisions. Now, let us move on to the birth of the star. In birth of the star, I have added two images in which the processes happening in the birth of the star would be explained very clearly, and I have added an text which will be read by the audio file. Yeah, like this it would be read. After that, if you have any doubts, we can go to the doubt session. But before going to the doubt session, let us move on and see all other slides. The working of a star. This I have added an image of a star's parts, and in the second image I have added like the process taking place, fusion of hydrogen into helium. Deuterium and tritium is being merged and giving one helium atom and one free neutron. And this also I have added the audio file of the text which I have added, and this slider will adjust the volume.
Like all other stars in the universe, the Sun is a huge, bright sphere of hot.
Yeah, as you saw, the slider adjusts the volume. Now let's move on to death of the star. In death of the star, actually we have two two subtopics: black holes and neutron stars. Black holes will form when the star is so massive that it is like 15 times more massive than our own sun. If it is less massive, then neutron stars and supernova will occur. Now let us first look at neutron stars and supernova. As you can see in the image, first image, it is showing the theoretical part, like the red giant. A star has been nearing its end of the life, and it is collapsing its own weight due to its own gravity, and it bursts out and leaves all its atmosphere, and in center we can see a neutron star. It is highly dense star. And the second image shows the image of a supernova. And here also I have added some text which is related to the topic, and we can also hear it by audio file. Now let us move on to the black holes. Black holes are very highly dense substances, which is now, for humans knowledge, this is the most dense substance found on the universe. In the first image we can see the parts of a black hole, and in the second image, that's a real image of a black hole taken by a highly magnified space telescope. And here also I have added some important points, not all the points, just the important points. And audio file has been added, and slider is here to adjust the volume. Yeah, now we have completed the whole timeline. Let us now move on to the doubts. All the doubts will, there would be many doubts which would arise for us, right? So let us try to ask the doubt. Yeah. What is a black hole made of? Star. After clicking the search, we will be getting the answers from Google directly, as I have added a web viewer to it. So it would be easy for the user to understand and go through the doubts which they had. Like, they don't need to go to Google separately and search. We have added this feature in this app itself. That's all. Thank you.